Hi, it's Jan Beta, and today's episode is probably going to be a special Patreon episode because I'm fixing something, or I hope to fix something that I usually don't work on, which is this thing here, which is also the reason why I'm in the not yet fully finished living room of my new flat. It's a TV I got for free. And what it does, when you try to turn it on, it doesn't even light the LED or anything, it just does nothing. Which leads me to believe that it's there's something wrong with the power supply of this thing, most probably. And yeah, we're going to check that out, I think. So let's disassemble this thing and see what's inside. Yeah, I laid this down on my bed. I'm sorry about the lights. That's actual sunlight coming in from the window, which is it's pretty uncommon for the part of Germany I live in. There's not much sun usually, but it's nearing the start of summer, so a little sun for a change. I already removed most of the screws. And there's quite a few here, which I have to remove, I think. So it seems an LD32 LD750, whatever that means. It's quite a nice LG, quite modern, April 2011, actually manufactured, it says. It's more recent than the TV I actually use, and I got this for free because it just broke down and didn't turn on anymore. And yeah, before it supposedly worked just fine, so I hope it's an easy fix. And what really makes this even more interesting for me is the quite huge variety of inputs it has, which makes it very interesting for retro gaming stuff and stuff. It has a component in, it has a AV in, a SCART connector, it has an RGB in, which is probably a VGA in. It has an RS-232 port for control and service. Probably you can make something funny with that too. Antenna in, of course. It has optical audio in and out. And 2 HDMI ports, which is pretty nice. It also has LAN, so you can hook it up to your network, which I think it's a semi-smart TV already, so probably some stuff on there. It's going to be, if I get this fixed, it's going to become part of the lab as my retro gaming monitor, my huge monitor for hooking up my Amiga or stuff like that. So this is going to go on the wall, I think, in the lab for various stuff. Hopefully, if I get it to work again. Otherwise, it's going to be scrapped, I guess. So let's see. I should just be able to pull this out. Yep. And then probably are able. I will put more screws. Now I should be able to just lift off the whole panel here, I guess. Oh, there's another screw here. Oh, and there's another screw here, which I forgot. Man, there's a lot of screws. Okay, so that's another screw. Coming away now? No, we are. I think now we're good to go. Righty. Okay, with all the screws removed, I think it should just be a matter of prying this up. And lifting this whole thing. Okay. Yeah, there's all the smart stuff. This is what I think might be faulty. It's the power supply section. Let's have a look. So this whole section here, I think, is the power supply. And I suspect that there's 1 or 2 fuses that's broken on there. I think we should take this whole assembly out and work on it in the lab, on the bench, which is much more convenient, I guess. It's quite convenient that this whole assembly just lifts out, so probably we could buy a new power supply section here, and would probably be fixed. Supply for the backlight, I think. Might be the backlight has a short or something like that. It's also a possibility. It looks pretty well made, I guess. I don't really have a clue if it's well made, but it looks reasonably well done, I guess. Capacitors are no-name stuff, so maybe there's a capacitor that's blown. Okay, so now I should be able to lift this out, which I am. There we are. There's ICs on the back there. Okay. So and I'm screwing these screws back in here, I guess, because I don't want to lose them. Oh, that's the wrong spot. So, and I want to make sure they go into the right holes again. So that's, I hope that's a clever thing to do. Okay, so here we are. Let's poke around with the multimeter, I guess. My first guess is that one of the fuses is probably blown. So I'm going to put this into continuity test and poke around at the fuses. By the way, you should, of course, short the big capacitors out before you start working on something like this, because they can store quite some energy. This wasn't on for a month. Okay, so this fuse seems to be blown. This one is okay. Yep. This one is blown, which is the primary fuse. So if the primary fuse is blown, maybe it's just the primary fuse that got a voltage spike of some sort, maybe in a thunderstorm or something like that, maybe lightning hit. It's pretty unlikely, but it might just be the fuse. They don't blow for nothing, but the secondary fuse seems to be perfectly alright. So usually you have a fuse blowing because there's a shorted component somewhere, which might just be the case here. But I don't see any obvious burned resistors or anything like that. Might be one of the capacitors, which would be pretty typical, or maybe something like the big transistors. But they usually, no, these seem to be alright. These seem to be alright. Okay, no, there I just hit my other test lead there accidentally. These are diodes. Double diodes. So they are supposed to be conducting this way, I think. They are not supposed to be conducting this way. Which they aren't, but they are supposed to be conducting this way, I guess. Which they are. Okay, so they are fine, I guess. Let's put this into diode mode. This is the diode mode. And you can, I don't know if you can see that, you can see that the diodes are alright. If they are alright. Yep, This should be 0.3 or something volts, I guess. And I don't get a good grip with my test lead there. Yeah, 0.26. Okay, are these different diodes or are these all the same diodes? No, they are different ones, so the difference in forward voltage is probably alright. Oh, the last one is a transistor, I guess. Yeah, it's a transistor. This one is a transistor, so yeah. Yeah, 2 point. Okay, the first one is another one than the other one, so it has a bit more of a forward voltage there. Here's another diode. Is this one alright? Can't even get 2 there. Okay. I have to check that from the other side. There's our diode. Yep. Yep. So these are alright, it seems. Can of course check those, the big diodes here. Yep. Yep. So the only thing that is really broken is this fuse here, which seems to be the primary fuse, just connected to the mains. So if that blew, maybe there just was some kind of strange voltage spike or something like that. Let's check around there if there's a short in one of those capacitors here, but it's pretty unlikely, I guess. These are resistors, which are pretty much shorts. Let's see. What are these supposed to be? I can't really read the code. So, and we have red and we have brown, which is 0.12 ohms. So these are the resistors. So they are supposed to be very low. So that's alright, I guess. Another diode to test, maybe. Oh, should put it in the right direction. Always the negative lead is always on the where the little line is on the diode. That's the direction. You got to measure these in. So these are alright. Yep. I think you should get half volt or something in the point something volts there, which is normal. So what about these? Are these shorted or anything? The disc capacitors? Nope, they're alright. It has a very low capacitance. Maybe there's a fault right there, but it's not shorted or anything. Okay, so this thing which I thought was a disc capacitor isn't a disc capacitor. It appears to be a thermal fuse. I'm just looking for the designator there. 15. Thermistor. It's a thermistor. Changes resistance with heat. So that's probably part of the of a shutdown mechanism if this gets too hot. So that seems to be alright, because it's no short. Let's see if it changes with temperature. Okay, I'm blowing cool air on it and it gets higher. So I don't really know if that is supposed to work that way, but doesn't seem to be faulty. So this thing actually is a bridge rectifier, which I can test with the diode tester. Should give me a diode here and a diode here. Yep, which it does. Let's check the other way around. Should be nothing and nothing. Yep. That's totally alright. Oh, sorry, you couldn't see the meter, so let's do it again. So this is the bridge rectifier. It should give me a diode here. You can totally not see the meter, can you? This is a diode, just the values we were talking about. This should be another diode, the other way around. So this should be a diode, and the other way around I should get nothing, which I do. There's overload, and there's overload. Okay. Sorry about the hand, but you have to trust me on that one. This seems to be alright. So the bridge rectifier is alright. This seems to be a thermistor. Don't know what it's supposed to be. The big caps seem to be alright. The transistors seem to be alright. The fuse is blown. So why would the fuse blow? Maybe it's one of these which are shorted, which could also be the case. Large filter caps there. High frequency filter caps. Nope, this one seems to be alright. This one seems to be alright, no short. And this one seems to be alright. So, oh, there's a silk screen on the back. That would have made things easier. Okay, so according to the datasheet, the thermistor should have 5 ohms at 25 degrees Celsius, and we have maybe 18, 19 degrees Celsius at the moment, so I guess 7 ohms are perfectly okay. So here's our power output, which is very conveniently marked. So I'm probably going to test that when I have the replacement fuse in, which I'm going to do soon. Some fuses on order. And yeah, I'm going to put in the correct one, because you should never mess with fuses and only put in the correct ones, or slightly lower values, or ever so slightly higher values. But if you want to be sure you don't damage anything unnecessarily, you should always go with the correct values. Which it also says on most circuit boards. For continued protection against risk of fire, replace only with the same type and rating of fuse. And our fuse here is a T3.15 amp fuse. Okay, so it's a couple of days later and I got some fuse holders and some fuses which are 3.15 ampere, which is the one that blew. This one here. And I'm going to replace it with a fuse holder. I hope I get this to fit in there. But yeah, I think so. Shouldn't be much of a problem. So let's desolder the old fuse and put in a fuse holder so we can replace the fuse multiple times. There we go. And there's these little reinforcement rings there that I think we might just leave in there, maybe, if it fits. Yeah, we have to bend these a bit, I think, but that's not gonna be a big problem. So I'm bending these a bit outwards so that they maybe fit. There's not much room in there. I hope it fits. Okay, so with some wiggling and some little adjustments, I got it in, and yeah, I need to solder this in now. Fuse solders in. Let's insert a fuse and yeah, slowly power this up, I guess. First of all, I think I want to reflow some of those solder joints and generally take a look at these. Maybe there's something that's a loose connection that caused the fuse to pop or something, although they all look pretty decent, I guess. So there we go. That's pretty much all the large solder joints reflowed. Okay, here we go. Let's add a fuse. These are pretty good brand ones. Schurter, which is a German, I guess, yeah, it's made in China, but it's a German brand. That's quite good usually. So I'm going to insert one of these. I have to bend the little fuse a little bit back into shape because I bent it too much while inserting it. So it's going to make good contact. And then, so there we are. That's our new fuse. 3.15 amps like the old fuse. So it should be fine. So I guess we won't fit the glass thinger over there, I guess. Ah. Yeah, it even fits the glass protector there, which isn't glass at all, of course. It's plastic. And it says fuse in nice reassuring letters. So maybe it should say don't panic. We're about to power this up and the fuse was blown. So I'm using something that I have under my table here, which is an isolation transformer with a variac. So an isolation transformer basically, man, it's a bit tough to describe in so little time. So what it basically does is protect me from being the connection to ground, which leads to current flowing through my body, which that prevents. So the isolation transformer gives me mains voltage, but is isolated from mains ground. So there is no connection to mains ground. That means I won't become mains ground, which is why you get shocked by mains voltage in the first place. So you touch it, current can flow through your body to ground. And if you use an isolation transformer, that won't happen, so you won't get shocked, which is a good idea in this case, I guess, working on open circuits like this. And also it's a variac, so I'm going to slowly raise the voltage to see if and when this blows. Okay, and here's what it looks like under the table, under the desk, in the new lab. This is my isolation transformer that I was lucky enough... I don't have to whisper, I guess. I was lucky enough to score this when it was about to be thrown out by the company that has its storage and repair stuff next to the company I work with. They threw out a lot of monitors and stuff like that, and yeah, I got some of the stuff from them back then, but the most interesting thing I got is this isolation transformer, which would cost 1,000 euros or something like that. I think it's rated for 8 amperes or something. Yeah, 8 amperes or something like that. So you can hook up really, really huge projects to this. It's basically an industrial size isolation transformer. And it has this beefy, very, very beefy variac thing. So I can adjust the voltage. Usually, when I turned this on in the old flat, it blew the fuse right away. So yeah, I'm pretty confident we'll blow the fuse in this flat too, but we'll see. So let's see what it does if I turn it on now. I always feel like a mad scientist doing this, so let's do it. Okay, didn't blow the fuse, which is a good sign. So I guess I'm gonna turn this off for now and connect my circuit here, which I think I'm going to lay on the ground in front here so you can see. This is under the table, so it's not very convenient, but if the fuse blows, I want to film that. If there's smoke, maybe, which probably won't happen. But we'll see. It's a 3 amp fuse, so maybe there's gonna be smoke. Okay, so as you can see, I hooked this up absolutely safely to the isolation transformer. Lay this on a piece of, I think it used to be some wardrobe thing or something that I picked up, which is pretty handy to have, like a piece of wood with a plastic coating to work on if you are not working on the table. So this is one of the more useful things I came up with. Also has some rubber stands too. Yeah, it's pretty, I like this and I use it a lot basically. So let's power this up slowly, I guess, and see if the fuse blows right away. Yep, there was a fuse in the flat that blew. All right, so let's put that back in. I told you so. Okay, let's try that again. Got the fuse back in. Let's do it again. Oh, wait, again. So we're going to disconnect this and try it again and see if it is that thing that blows. Okay, let's try that again without the circuit connected. Oh yeah, okay. So this thing blows up right away, I guess. Let's try this again just to evaluate. Oh, okay, there was our explosion. That blew pretty violently. Wow, okay. There was definitely a short in our circuit there. Okay, let's check the fuse. Yep, fuse is blown. So, yeah, there's still something wrong with the circuit here. So, this thing apparently is pretty broken, and I don't know if you can see it nicely on camera. There's where it sparked. It's this little transformer. And yeah, I googled and I looked for this part to replace it because yeah, I suspect this was the reason why the fuse blew in the first place. Short in this transformer or some arcing or stuff like that. So yeah, now it basically it's burned. So this is cactus, and I would have to replace this part, but unfortunately it's not that easy to get a transformer like this because I don't know anything about it basically, except for the stuff that's written on there, which doesn't seem to have anything to do with anything really. So yeah, that was the component I was looking for. I couldn't find it, so I ended up, because it wasn't that expensive, given that I probably get a working TV, I ended up buying this, which is a new old stock board that has the exact same part number, which is written in the corner here. This is the number. There are similar boards that have different numbers. You should buy the one that is suitable for your television, obviously, which I hopefully did. I think so. compared the numbers, and yeah, this is the one I need basically. So I think we should put this into the TV. And I should place the little standoffs here in the TV, in the positions they belong, before I do that, because yeah, they are needed in the television to space it. By the way, the background noise you're probably hearing is from my computer, because I'm rendering a new video at the moment. So I'm just going to put this into the television. Okay, here's where it gets exciting. Going to connect the cable. Plugging it in. Okay. Oh, there we go. Okay. That's working. It seems. No signal. Okay, that's what I want to hear. Nice. Yeah, there we go. This seems to be a working television now. So I totally have the remote for this. So I'm just going to AV1. And there we go. There's my Super Nintendo that I... That's pretty cool. And I have to set this to auto. It should give me 16 to 9. No, 4 to 3. The hum you're probably hearing is from the cable. I definitely need a new Super Nintendo RGB cable. This one hums. So yeah, but otherwise, this seems to be working perfectly nice. It was just the power supply that was broken, so this is going to be probably my monitor in the lab. This is pretty unbearable. This is going to be my monitor in the lab, I think. So yeah, that was this repair, which wasn't really a repair, but a replacement of the power supply board. But yeah, maybe this is a hint into the direction that you don't throw away stuff like this, and rather either give it to somebody like me who will have a go at fixing it, or try yourself. And as you've seen, it's not rocket science if you're just replacing the board, which probably everybody can do that can hold a screwdriver. So yeah, this is a fully functional television now with 3D and a lot of inputs for consoles and stuff like that. So this is pretty handy. So anyway, thanks for watching. Hope you like this. This is going to be a Patreon special, and I'm going to keep it that way because yeah, it's not quite in the same. It's not quite the same as my other stuff. So yeah, hope you enjoyed this. Thank you so much for your support, which also made possible that I bought a power supply board for this, which was around 50 euros, I believe, that I took. I took the risk to do it because I knew I had the money to do it from your support. So thanks very much, and see you all very soon. Bye!